Okay, everybody, welcome to Secondary Math 2 Honors and the start of a new school year. So we're going to start out this year with Chapter 2, Polynomial Equations and Factoring. In this chapter, there are 4 different standards that we're going to go over, you're going to learn, and you will be tested on. The first 2 standards, that A.SSE.1 and that A.APR.1, are going to be the first half of the chapter, and then the second 2 are essentially going to be the second half of the chapter. So when we start here, we're going to start with 2.1. And we're going to specifically look at identifying and interpreting parts of a polynomial expression. If you don't know what a polynomial expression is, that's fine. We're going to learn it. And then the second one, after we know what a polynomial expression is, we're going to perform operations on those, which means we're going to add, subtract, and multiply. So those are going to be the first couple sections, and I will go over these standards again as we get there. And then we're going to leave the second 2 for the second half of the chapter. Now, moving on. Before we actually add and subtract our polynomials or look at what a polynomial is, we're going to take a step back and we're going to look at properties of real numbers and try to remember what those were. Now, if you are at home and you have a printer, I would recommend printing the guided notes that were provided because they're going to look exactly like what I go through, and you can just jot it down on the piece of paper. If you don't have a printer, that's absolutely okay. Just get a notebook, get a blank sheet of paper, get something that you can take notes on and keep. So just like you were sitting in class, you're going to need to have all of this information so that you can go back and study and do what you need to do. So, properties of real numbers. We've got this kind of grid, this kind of chart here. We're going to start with our smallest box down here on the left. And when I say real numbers, I'm talking literally about numbers. So like 1, 2, 3, those are numbers. Okay, and the smallest group of our numbers, if you remember, are called our natural numbers, also known as our counting numbers. So put yourself back in kindergarten, maybe in preschool, when you're first learning about numbers. Typically you start with 1. So 1, 2, 3, 4, etc. Those are your counting numbers. That's how you learn how to count. That's our smallest group of numbers. Now, a little bit bigger than that, you're now moving on from kindergarten to first grade. You're getting older, so you have a better idea of numbers. We're going to move on to our whole numbers. And the difference between your counting numbers and your whole numbers is we're going to add on 0. 0, 1, 2, 3, etc. Moving a little bit bigger than that, now we've thrown 0 in, we've got 1, 2, 3. What if we go the opposite direction? Okay, there's more numbers than just 0, 1, 2, 3, and those are called your integers. And your integers are your positive and negative whole numbers. So ... -2, -1, 0, 1, 2, ... Those are your integers. Now, moving up from your integers, we have even more. And most of you are now thinking, okay, well, what about like our fractions? Okay, so we also have fractions where we can put all those numbers on top of each other, and those are called your rationals. Okay, so rational numbers. Now, rational numbers kind of have a couple different things in here, and the first one is, of course, your fractions. So fractions, for example, 2/3, 1/9, etc., 1/2, 5, 7, anything you can write as a fraction is a rational number. Also, you have terminating and repeating decimals. So by terminating, I mean ones that stop, they terminate. So for example, we could have 2.5. Now if you think about 2.5, 2.5 could also be written as a fraction. It would just be an improper fraction. It would be upside down. And then repeating decimals, we're talking about like 0.666 repeating, which if you think about that is really just 2/3. So 2/3 is 0.666 repeating, 1/3 is 0.333 repeating. You could also have something like 0.325, 325, 325, 3. Anything that's going to be repeating is going to be a rational number. So we started small with our counting, we got a little bigger to our rational. Now if I go outside of that box into the next box, well, that's the whole box. which we're going to talk about in a minute. But before we do that, I want to jump over here to this other box that you see on the right-hand side, who's kind of detached. He's not really part of this other nice numbers. Our rational numbers inside that box are nice numbers. So now we're going to go look at our non-nice numbers, and those are your irrational numbers. So irrational numbers I usually like to think of as more like not nice. They're not nice fractions. They are not terminating decimals. They are not repeating decimals. So two of our most common examples, you're looking at like your square roots. And when I say square roots, I mean not a nice square root. So square root of 2 doesn't come out nicely. It's going to be some weird decimal that never repeats, or even something like pi. 3.14, etc., 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 etc. That's not really a nice number. Okay, if you know what the number e is, that would also be in this category. You could look at like the square root of 7, anything like that. Now, the whole box, which at the moment everything is inside. Okay, so now we're looking at the whole box. Everything inside of there are our real numbers. So real numbers at this point in your mathematical career is what you have dealt with. Eventually this year we start looking at non-real numbers, which are going to be outside of this box, but we'll worry about that when we get there. Okay, using this information, you're given a set of numbers, list the following. So first of all, I want to know which out of this list are your natural numbers. So take a look at it, see if you can figure anything out. Keep in mind your natural numbers are also your counting numbers. So 1, 2, 3, 4, 5, etc. And I hope you're identifying we have the square root of 25. Because yes, that's a square root, but square root of 25 is actually just 5, because 5 times 5 is 25. So 1, 2, 3, 4, 5. There it is. Okay, now whole numbers. Keep in mind whole numbers, you just add on 0. So 0, 1, 2, 3, 4, 5, etc. And I'm looking at my list, and it looks to me like there is no 0. So does that mean there's no whole numbers? And the answer is no. Because if the square root of 25, which is actually just 5, is a natural number, that means it's also a whole number, because it's in that smaller box, which is encompassed by the whole numbers. Whole numbers are natural numbers, but you add on 0. So 0, 1, 2, 3, 4, 5. Bam, there it is. Okay, integers. Integers are positive and negative whole numbers. So the first thing I'm going is, well, wait a minute. Square root of 25 is a whole number. It's a positive one, so it must also be an integer. But now I'm looking at my positive and negative whole numbers. So do we have anything else up here? And the answer is yeah, -3. -3 is just a negative whole number. -4/5, nah, that's a fraction. 0.25 is a decimal. Square root of 2, I don't even know what that is. 7.4, that's a decimal. So let's move on to our rational. So rational is integers, whole numbers, natural numbers. Rational is that bigger box, which is everything. So once again, I'm going to copy down my square root of 25 and my -3. But then I'm going to go, okay, but rational is also my fractions, my decimals that terminate, and my decimals that repeat. So I'm saying, okay, well, I've got a fraction. That's -4/5. I've got 0.25, which is a terminating decimal. It's also 1/4, which could be written as fraction. And then I've also got 7.4, which is a terminating decimal. Moving down the list, irrational. Now, irrational, remember, is in that separate box off to the side, which does not encompass the rational numbers. So we've been copying this list, not copying anymore. Irrational is your not nice, not terminating, not repeating, not nice, which is going to leave us with that square root of 2. If you put that in your calculator, it's just going to give you something point something something. I think it's like 1 point something something, and it's just going to keep going off randomly. And then last but not least, the real numbers, and all of those are real numbers because they're all in the huge box.